algebra students, welcome back. We're doing section 9.3, example 3, and now we're moving away from exponential growth and we're starting to jump into exponential decay. So this formula should look pretty familiar to you. Let me put growth here beside it so we can compare them. This is what we did in example 1. And what is the most basic difference between these two formulas? They look almost exactly identical except for one feature, and I bet you see it. Do you see that the sign here, 1 minus r for decay, 1 plus r for growth? Remember what I told you in section 9.2. If b is greater than 1, if b is greater than 1, b is the number that's being raised to the exponent. If that number is bigger than 1, you're going to have a number that is growing. But if that number is less than 1, it's a decimal between 0 and 1, your number's not going to be growing. You're actually going to be losing some value there, whether it's a population count or it's a dollar amount, whatever it is, okay? It all represents the same things as it did in the other problem, okay? Y is your final amount, A is your original amount. Could be the original population, original amount of money, whatever it is. R is your rate of decay, that's a percentage, and you're going to turn it into a decimal. T, of course, is time, okay? So let's take a look. You need your calculator. So I like practicing writing these formulas because if I write them enough, it's going to start to sink into my head. So if you're like me and the way you learn, it might be just for you visual people, you just may need to see it written down. Even say it out loud to yourself as you're writing it. Y equals A times the quantity, 1 minus R raised to the T power. You may just need to say it a couple times and you'll get it. All right, so the population of a town is decreasing, so that's key, decreasing at a rate of 1%, okay? We're going to remind ourselves we need the decimal form of that number, so we'll go ahead and change it to 0.01. In the year 2000, there were 1,300 people. So that's important because that's your starting amount. Write an exponential decay function to model this situation. So that's what we're going to do first. And then we'll actually calculate the population in the year 2008. Okay, so let's plug in. We're going to plug in for A, 1,300. And then we're going to plug in for R, 0.01. And there is the function, okay? That's the function that they asked us to write. That's the first thing they asked us to write. So you're going to fill in for A and for R. You don't have to write anything for T just yet. That's the basic function, okay? Now, let's take that, and in our effort to solve it, we need to plug in for T. T is the time frame that's going by. It says that the population is decreasing at a rate of 1% per year. So we need to figure out how many years there were between the starting number 2000 and 2008, which is what they told us right here. And so hopefully you're like, oh, well, T has to be 8 years. 8 years have passed, and you would be correct. So in your calculator, you're going to plug in 1,300 times the quantity, 1 minus 0.01 raised to the 8, okay? So have your calculator handy. And right after you write it down, go ahead and key that in just like you see it. All right, I've got mine. Now, you're going to get a decimal. We're not working with money. Now, if we were working with money, I would tell you round to the nearest penny. This is not money, this is people. And so we're not going to have half a person. What is the population approximately if you round to the nearest whole number? Remember, 0.5 or higher, round up, 0.4 or lower, leave it the same. And I have approximately 1,200 because I got 1199.568103 on my calculator. I'm going to take that 0.5 and go ahead and round it up to the next whole number, which would have made it 1,200. Okay? So that's how you do it. It's just like example 1. So I'm going to leave this one for you, and we'll check this one tomorrow in class. Good luck.